As you should already know, Amazon RDS is just a managed database service for several flavors of popular databases, and it's best suited for structured relational data. It aims to be a drop-in replacement for existing on-prem instances of the same database flavor, and it also automates a lot of the administration, such as backups and patching. And you can define certain customer-defined maintenance windows where these backups and patching occur. It also offers push-button scaling and replication that takes some of the hassle out of managing a database. If you can use RDS, I highly recommend you do so, because it's going to make your DB administrator's life much easier. In the big book of words that architects use sometimes to try to sound smarter, I present to you anti-patterns. Anti-patterns really mean just don't do that. And so I wanted to go through a few anti-patterns for RDS. And this is relevant on the exam because you may be asked situations where you would use one data store or one database over another, and you need to know what the proper use cases are. So if you need to store a lot of large binary objects, or blobs as they're sometimes called, S3 is probably the best place for that. If you need automated scalability, DynamoDB takes care of that. If you need to scale an RDS database, then you're going to have to change the instance type. If you have name value paired data structures, then DynamoDB and NoSQL or any NoSQL platform would be much better than a relational database. And if your data is not well structured or it's very unpredictable, DynamoDB or another NoSQL database is really a better choice, because it's very difficult to build a schema, a table and field schema in a relational database to support unstructured and unpredictable data. If you need to use another database platform that's not supported by RDS, well, obviously you can't use RDS. You can use EC2. Examples of this are DB2 or SAP HANA. And if you need complete control over the database, EC2 is your option there. Because RDS tries to commoditize the database, it doesn't provide you with a lot of access to the deep, dark features of a database engine. And if you need access to those, then EC2 is your better option. In our example here, we have the master database in US West 2A, and then we have the two standbys in the other AZs in US West. We've also set up a read replica in Europe and in Asia to service the users that are located in those regions. Note that to use replication, you have to use NODB, or ExtraDB as it's known on Maria, because non-transactional storage engines like MyISAM do not support replication. Of special note here is the type of replication. Now, in a multi-AZ implementation, the replication between the master and the standby is synchronous. So as soon as that transaction gets committed, it's instantly replicated to those other standbys. And that's a good thing, because if the master fails, the standbys stand up and say, I'm now the master, and I have all the data that the master had. In contrast, read replicas are asynchronous replication. Now that doesn't mean they're way out of date. It just means maybe they're lagging a few seconds, or maybe even a minute or less, with regard to the writes that are occurring on the master. Let's say that for one reason or another, our master died. Well, in a multi-AZ deployment, one of the standbys automatically gets promoted to the master, and it also continues to serve as the master for the read replicas. Now, in the case of a whole region failing, we can promote one of our read replicas, but it's a bit of a two-step process. So we have to promote the read replica to a standalone, a single AZ instance, and then we can reconfigure that single AZ to be multi-AZ. Now, you could script the promotion of a read replica based on CloudWatch alarms, for example, but promoting a read replica is usually a big deal. And in this case, you're losing a whole region. That might be something you want to do manually, just to be sure that it's really what you want to do.